Welcome to Analog Microelectronics Circuits Lab. I am Nitin M, Assistant Professor, Department of Electronics and Communication Engineering. In this session, we'll see how to conduct an experiment in Analog Microelectronics Circuits Lab. Experiment title is Design and Testing of Full Wave Bridge Rectifier. As you all know, rectifier is a circuit which is used to convert AC into DC. So the main objective to conduct this experiment are design a rectifier circuit for a required DC output voltage and to measure performance parameters like rectification efficiency, load regulation and ripple factor. Before doing the experiment, we'll see what are the different components and equipments required to conduct this lab. Now let's see what are the different equipments and components required to conduct this experiment. First, we need a transformer, a digital ammeter, cathode ray oscilloscope with BNC cable and patch cords. We need a spring board, and the components required are 4 PN junction silicon diodes, 1 potentiometer and 1 resistor. This is the step down transformer which is used to step down the 230 volt AC mains to a particular voltage. Here we are using a 12012 step down transformer. The output between these 2 points we will get 24 volt RMS, and if we are taking between these two we will get 12 volt RMS. Now this is the digital ammeter which is used to measure the load current, and this will be connected in series with the load devices. Now this is cathode ray oscilloscope which is used to see the input as well as the output waveform. The input and output are given to the CRO using this BNC connector using this patch cords. This is a spring board which is used to set up the circuit to conduct this experiment. Now in this experiment we need 4 PN junction silicon diodes, 1 10 kilo ohm potentiometer and 1 100 ohm resistor. So this resistor and potentiometer together act as a load, so that we can, by using this potentiometer, we can vary the load resistance. Now this is the main component which is used to conduct this experiment. This is a PN junction silicon diode 194007. You can see the plus and minus terminal of this diode. Minus terminal is denoted by using a silver band. This is a circuit diagram of full wave bridge rectifier. The circuit should be connected as per the circuit diagram. The connections are done as per the circuit diagram. Now you can see, as in the circuit diagram, the 4 diodes are connected in this fashion. Now the input to the circuit has to come from the step down transformer. So you can see the step down transformer here. These are the 2 connections from here. So I have directly connected from this point to the spring board over here, and now the input to the circuit has to come from these 2 points. Now the diodes are connected in this fashion. Now the input to the circuit has to be applied between this point as well as this point. So you can see this red wire connected from this point to here, and the black wire again connected from this point to here. So this is directly connected to the step down transformer, so that now the input is applied to the circuit. Now the output has to be across the load devices, and the load devices are connected between this point and this point as shown in the circuit diagram. Now we know that here we have a 10K potentiometer and a 100 ohm resistor. So this is 100 ohm resistor and this is 10K potentiometer. These 2 are connected in series, and these 2 are connected across these 2 points. Now one of the important parameter that we need to measure in this experiment is load regulation. If I want to measure load regulation, I need to know how much load current is flowing. In order to measure load current, digital ammeter is connected in series with the load devices. So I have a 100 ohm resistor and a 10 kilo ohm potentiometer. So an ammeter is connected in series with these 2 components. So potentiometer, 100 ohm resistor and ammeter are connected between this point and this point. Now as we discussed before, a rectifier is a circuit which converts AC to DC. And this circuit is a full wave bridge rectifier. So what we are expecting at the output is rectification for both half cycles. Now we'll see the full wave rectified output in the CRO. So the outputs are taken between these 2 points. So I have connected a red wire from here to this point, and again one more black wire from here to this point. So outputs are ineffectively, I am taking output between these 2 points. Now I'll connect the output to the CRO. And I'll turn on the CRO and I'll release the ground button. Now you can see the full rectified output. The rectification happened for both half cycle, positive as well as negative half cycles. As you have seen the rectified output now, you can measure the performance parameters like ripple factor, rectification efficiency, and load regulation. So the first thing, to measure ripple factor, you should know the AC voltage as well as the DC voltage. Now the output can be seen in the CRO. At the same time, you can connect a multimeter across the points and you can measure the AC voltage and DC voltage, and the ratio of that will give you ripple factor. Now the second parameter to measure is load regulation. Now in order to measure load regulation, we have the formula V no load minus V full load by V full load into 100. That will give you the percentage regulation. So in order to get the voltage corresponding to no load means there is no load current. Now in the ammeter you can see there is almost 99 milliamps or 100 milliampere current is there. In order to measure V no load, we have to turn the potentiometer to its maximum so that there will be no current through the load. Now you can see the reading in the ammeter is 0. So the DC voltage corresponding to this condition is known as V no load. There is no load current. That measurement can be done using a multimeter connecting across the load device. Now in order to measure V full load, V full load means full load current, and you will get full load current when your potentiometer is in its minimum. So now the potentiometer is at its minimum point and you can see the maximum current flowing through the load device, that is almost 99 milliamps. So with the DC voltage corresponding to no load as well as full load condition, you can measure load regulation. So in this session, what we have seen is how to set up a full wave bridge rectifier circuit, and how to see the output waveform in CRO, and how to do the calculations for load regulation, ripple factor, and rectification efficiency. Thank you.